Hi everyone, this is lesson 4.4 on dilations. A dilation is a transformation that is different from the ones we've studied so far. To date, we've looked at translations, rotations, and reflections. All of those were isometries. In each of those, the image and the pre-image were congruent. Dilations are different. They are not isometries, which means that the image and the pre-image may not be congruent. In fact, generally speaking, they will be different sizes. The essence of what a dilation is. You've encountered the word dilation before if you've ever had an eye examination. Please fill this out on your own. A dilation has two major components, a center and a scale factor. A scale factor is what affects the size of the image. If you have a scale factor of 2, for example, the image will be twice as big as the pre-image. A scale factor of 10 will be 10 times as big as the pre-image. That will also affect how far away the image is from the center. With a scale factor of 2, the image will be twice as far away from the center as the pre-image was. So the distance from the center will be multiplied by the scale factor, as will the size of the image. To see this more clearly, here is an animation using GeoGebra. This dilation has a scale factor of 2, so the image is twice as big as the pre-image. It is also twice as far from the center. If we change the center, you can see that the image is in the same direction as the pre-image from the center. If we change the scale factor, the image gets farther away. A scale factor of 3 means that the image is now 3 times as far from the center, wherever the center happens to be. The image is also 3 times as big as the pre-image. Both of these are examples of an enlargement. There are two types of dilations, enlargements and reductions. An enlargement obviously results in an image that's larger than the pre-image, while a reduction results in a smaller image. In this case, the scale factor is 1/2. That means the image is half as big as the pre-image, and it's half as far from the center. So in fact, in a reduction, the image will be closer to the center. Notice that the image will always retain the same shape as the pre-image, just a different size. I'll make this file available to you on the website so that you can play with this if you'd like. In the first example in the notes, we're asked to dilate the image from the origin with a scale factor of 1/3. So we want an image that is 1/3 as big, that is 1/3 the distance from the origin. To do that, we can look at the coordinates. Point A is at -6, 6. 1/3 of the way from the origin to point A is going to be at 1/3 the coordinates. Point A prime will be at -2, 2. 1/3 of the distance from the origin to point B is going to take us to 0, 2. 1/3 of the distance from the origin to point C is going to result in its image point being at -2, 1. Point D, which was already at -2, 1, is going to go 1/3 of the way. And so we're going to get some fractions. It will be at -2/3, 1/3. Here's my best guess. Now I can connect points A prime, B prime, C prime, and D prime, and wind up with a shape, the image, that's been scaled to a factor of 1/3. We're also asked to classify this as an enlargement or a reduction. It is obviously a reduction. Our second example has us dilating an image from the origin again with a scale factor of 2. So the image is going to be twice as far and twice as big. Take a moment and give this a try. Point B is 2 units from the center along the x-axis. Point B prime is going to be twice as far, or 4 units from the origin along the x-axis. Point C was 5 units to the right and 2 units up from the origin. So C' is going to be 10 units to the right and 4 units up. Point D was 2 units to the right and 3 units up. So D' is going to be 4 units to the right and 6 units up. Point A at 1, 1 is going to be twice as far in both directions. New coordinates will be 2, 2. We connect the dots to form the image. Finally, we're asked to classify this as an enlargement or a reduction. The image is larger, so this is an enlargement. We can also tell by the scale factor. The scale factor is greater than 1. Therefore, it's going to be an enlargement. A reduction would have a scale factor between 0 and 1. Next, we look at how to determine coordinates of an image point. If we have a dilation of 4 from the origin, we have a fairly easy rule to follow. Whatever the coordinates are, they will map to coordinates that are 4 times as far. This makes for some easy calculations. 3, 5 will map to 12, 20. Negative 2, 1 will map to negative 8, 4. We simply multiply each coordinate by 4. Take a moment and try the next one. This time, we have a dilation of 1/2. That means this is going to be a reduction, and our rule is going to look like this. Verify that you're getting the same answers. Finally, we take a look at a graph and identify the scale factor from the following dilation. First thing we need to do is identify which is the image and which is the pre-image. Since we're not told, we have to make an assumption based on the notation. A is typically used as a pre-image. Anything with a prime is typically used as an image. So, the pre-image is quadrilateral ABCD, while the image is quadrilateral A', B', C', D'. We're not told where the center of dilation is, but since all our examples so far have had a center at the origin, we're going to make that assumption today. If you're ever unsure about where the center is, please ask your teacher. The simplest way to identify the scale factor now is to locate a point in the image and the point in the pre-image that both have integer coordinates. That'll be the easiest to read. The only ones we have are B and B'. We can see that the distance from B to the origin is 8, while the distance from B' to the origin is 2. This makes the image 4 times as far from the origin, and so the scale factor is likely to be 4. We can cross-check by estimating the coordinates of the non-integer points. For example, we know that D is at 1, 4. Is it reasonable to assume that D' is at 1/4, 1? Well, the y-coordinate certainly looks like 1, and the x-coordinate looks very close to 1/4. So that's reasonable confirmation. Thanks for watching.